Okay, uh, I make the other side of the network based on the VMware Net 2, number 2. As you can see here, here in the config, we can see VMnet 2, and in the server number 2, you can see setting and the network setting here, the VMware host 2, okay, host only. And I'll show you the ping is correct. 139.2 is for server side PC2. You can see ping here, and also you can see the ping from the server to the router number 2. Okay, the router gateway. Okay. In the next step, I want to connect between two routers because the more like to real environment, I select the serial interface to connect between two routers. Okay, so I select the link serial 10 to serial 10. Okay. Sometimes let me to comment on the software VMware and the software of GNS3. Sometimes we encounter some problems, some bugs related to these software's connections between together, and you should restart your computer or you start your systems again, your software again. Okay, as you can see here, you cannot see the connection between them, between these two routers. However, maybe it is connected. After I configure the routers, I will start again this program to show you the connection. Let me to configure the router number 1. I will consider the IP address 11.1.1.0 as a classless address of WAN connection here, the WAN connection here. Okay, here is a WAN connection between two routers. Okay, config for router 2, and the site router 2 will be 11.1.1.2. Replace serial check the serial 10. Serial 10, the address 112 subnet mask. It is the class A address. However, I use the classless addressing for more clarify to nearest IP between these systems. As you can see here, the connection is appear here. This problem was because of the speed of the system's processing. Because the system processing right now is very high because you are running the VMware with two operating system related to routers and the VMware with two virtual machines. Once you add some virtual machines or some communication devices such as routers, switches, or anything else, your processing will be increased. Okay, no shot. Here is a very critical recommendation to connect between serial connection. In the serial connection, we need to consider the synchronizations and determine the bandwidth and the clock rate to connect between two serial interface. As you know, between serial interface, you need to determine how long each one or each zero will take the spend the time, and so you should determine the data communication equipment. You should determine DCE or data communication equipment in one side of the serial communication. If the serial communication directly connect between two routers without modem, you should determine DCE. I determined the DCE for this connection in the R2 side. Okay, so with the command clock rate, and the, as you can see here with the question mark, you can see DCE clock rate based on the beats per second. I use the clock rate 64 kilobit per second. Okay, and bandwidth is based on kilobit. Okay, so here here I gonna to connect configure the router 1. Okay, here router 1, router 2. You can switch between two tabs. Config T, and again interface serial 1 0. Let me to show the serial interface. Let's show the IP address here, and let's need to add another IP address for the WAN link 11.110/24. IP address 192 sorry 11.11.111.255.255.255.0. My colleague tell me they increase the volume of speaking. Okay, and no shots here. Okay, let me to test the link between two routers R1 and R2 in the WAN link in the network area number 11. Ping to ping 11.111. It's okay. 112. It's okay. However, if you ping from the serial interface 10 of router 1 to another network such as this network, because it is a hub between this network, you cannot ping here right now. You cannot ping here right now, maybe, because here you have a hop between this network, and you need to configure the routing protocol to route the packets from a network to another network. So let me to test all of network here. Okay, so ping from 19 to 168 to 183.1 from other interface of router 1. It's okay because there is no any hub between this network, just R1 to R1. This is the connected interface. You can see the here, you can see here the with the show interface to show interface, show routing protocol, show IP route. With the command show IP route, you can see all of routing connection that this which router 1 can detect the routes. Here the route the network 192.168.183.0/24 subnet mask is directly connected to the fast Ethernet 0, and the 11 network is directly connected to the serial interface. This is the label C. Label C means connected directly. Label R means the routing protocol RIP used, and the other routing protocol. I will use OSPF routing protocol here for this network to connecting between this long distance routing. Okay, so I have no any route to the network 1390. You can see here there is no any route here. I will add this network by the routing protocol. Okay, so let me to add this one step backward with the router sorry router OSPF and OSPF process ID. The process ID is the ID for each process of routing protocol in the OSPF protocols, routing protocols. Okay, we have two sort of routing protocol: link state protocols and distance vector protocols. The OSPF protocols is better than RIP protocols because it is more intelligent. The network command for determine which network should be determined for this router. So I should determine the route, the network 192, sorry, 168.139 and 0. Okay, for OSPF network, we have to use the wildcard mask. The wildcard mask is reverse of the subnet mask. Our teacher will talk about this in next sessions. The wildcard mask also used in the access control list. You should determine the area 0. Area 0 in the OSPF is the core network. All of other network in the OSPF topology should be connect with the area 0. Area 0 is a core. Okay. So let me do save it, copy, run store. Okay. So in the R2, let me go to the R2. Exit. Setting the routing protocol. I want to connect between the server PC1 to PC2. Maybe in the next time we want to replicate replication server in the Active Directory between two servers. and we want to add another servers as exchange servers with the additional router maybe, and or additional internet connection in the next step. Here in this project today, I want to connect between two clouds or two Windows server. Router OSPF process ID 100 network. Okay. Wildcard mask area core network. Okay. Let me show you router, show router with show IP routing table. It is the routing table. Let me to show you routing table here. Okay, it is empty. I should here check it. Okay, I should add another network here. In the router one. Okay. In the router two. Okay. As you can see here, add the other route in this table as a routing table here that show you all. All means OSPF routing protocol used in this routing table. And this is the metric. This is the metric for determine the value of this route. This is the metric for value of this route. This is this number 110 means the routing protocol of OSPF metric. This is show the routing distance. Routing distance of this routing protocol of OSPF is 110. The routing distance of each protocol, if the routing distance of each routing protocol is less, means that routing protocol is better. For example, the connected routing is the best routing, so the routing distance metric is very low. Okay, here I should ping from the router to this interface to this network, this interface, because I have one host between this. Okay, ping 1 2 0 1 8 3 1. Okay, okay, that pings. That ping, okay. And I want to ping the server, a step-by-step ping. Number 2. Oh, okay, okay. And from the server to server 2 to server 1. Okay, let me check here. I hope this thing work correctly. Okay, ping. This is the server 2. Okay, let me show the topology. The server 2 should be ping 198.168.183.2. Okay, 183.2. Okay, so the end-to-end connection between a WAN area is work. I will show you a step-by-step, hop-by-hop routing here, such as when you connect to the website around the world. Let me to show you the name of this city. This is Toronto router, and this is the Ottawa router. Okay, so this long distance area connection established between two servers, exactly such as real environments. We can design the replication between two servers in the next step, in the next session. Okay, thank you to listening to me. Before ending this process, this video, let me to show you about the trace route command. Trace route command, trace RT, show you the step-by-step, hop-by-hop ping and the IP address of each hop here. Okay, so let me to trace RT in the end, the very end destination here. 188.183.2. Okay, another server. Okay, you can see here, this is the gateway of the route, the server 2, and this is the WAN area IP address here in the picture, in the topology, and this is the end server in the end network. Okay, okay, so in the next video we will prepare the replication server, and even we will connect the Linux server to this topology. Okay, thank you to listening to this video.